Tyrosine is very similar to phenylalanine. It's aromatic, except it has a hydroxyl group added on. So let me draw it. Alpha carbon, carboxyl group on the side here. And amine group on the side here. And it kind of, if you want to think about it, it's like transitions. You have alanine transitioning into phenylalanine, transitioning into tyrosine. It doesn't actually go alanine to phenylalanine, but you do make tyrosine from phenylalanine just by adding this hydroxyl group. You can see it on the side here. It's got this large benzene ring as kind of a prominent feature, but it is polar because it has this polar oxygen here in this hydroxyl group. You can see how they drew it. Here's the alpha carbon and side chain. So here it is down here, tyrosine, pKa of 10.1. So it's a little different than the other pKas that we've seen. In this case, because cellular pH is more acidic than 10.1, this will be more likely to have a hydrogen on it. So before pKa was showing how it was ionized usually, and now the pKa is showing how it's not usually ionized. So here's what we saw before with phenylalanine, is you can convert phenylalanine into tyrosine, and then from tyrosine you can go to dopa, dopamine, norepinephrine, and then epinephrine, which are noradrenaline and adrenaline. And we talked about this, I think, briefly maybe when we talked about the serine threonine kinase. Tyrosine kinase is a similar kind of a enzyme where it's able to add a phosphate to tyrosine. And since I've shown it before with those other amino acids, might as well show here. You have a phosphate, and this will be attached to adenosine triphosphate molecule. It's the gamma phosphate on the end of the chain of phosphates. Well, I guess just to kind of show that there'd be, a chain of phosphates. And so this is the one. Then you have a adenosine connected there. But I'm just going to draw the phosphate as if it was kind of floating in the air, or the cytoplasm. And I like to draw a bunch of negative signs on here, but they might also just have hydrogens attached kind of randomly. So it is a dehydration reaction. I'm not sure which oxygen is going to be removed, but we'll just show it as this one. So there's oxygen that gets removed and becomes a water molecule, and then this oxygen will be bound to the benzene ring side chain. So this would be a protein, amino acid on a protein getting phosphorylated. And they show it here as hydrophobic, but it's kind of in between. It has that polar end to the side chain. So tyrosine here has a negative 1.3 as the hydropathy index, which indicates that it is a hydrophilic molecule. The symbols TYR and Y, T was already used for threonine. And you can see here it can also be called hydroxyphenylalanine because it is phenylalanine with just the hydroxyl group added on. It's non-essential. We just saw that it can be created from phenylalanine. And it's named after cheese in Greek, which Thierry, if you eat a lot of pteropodas, maybe you know Thierry means cheese. And it has 2 codons. And I didn't mention this before, but with a benzene derivative added onto a molecule, it's called a phenyl group. And so that's where phenylalanine got its name, was from the phenyl group. And then we saw that it's adding a hydroxyl group to that phenyl group to get a tyrosine. And I was just going to mention again that it's going to be called hydroxyphenylalanine.